I as usually ask. So, what are the different perspectives we see the nature? You can answer so that some revision also will happen.
Nature as a model, nature as a measure, and nature as a mentor.
Yes, 3M model. Okay, so as a model, measure, mentor, right? So, as a mentor, what is the philosophy we are going to look at? The innovations. If you consider nature as a uh, mentor, then what is going to be your innovation philosophy? Mentor. What happened? I generally revise in order to make you remember everything so that whatever you read that is going to be extra to that one. Okay. So
Yeah,
for reading the PPT again, it's not needed.
we take nature as a source, a guide to the correct solution.
Yes. Nature as a guide to the correct solution. So you create new technologies, but still they may not available in the nature. So that is only a mentor guide you towards something. Okay. So what are the different levels? We will look at the natural systems. Anybody? What are the different? We will look at the natural systems.
Organism level, behavioral level, and ecosystem
Hmm.
level.
Yeah. Organism level, behavioral level, and ecosystem level. Yes. Krishna Sai also wrote the same thing, and no, instead of messaging, you may speak, no problem. Okay. So Praneeth, some others also messaged. So instead of that, you please speak. That's better. So that I feel somebody is communicating. It's instead of a one-way communication, it can be better thing than this. Okay. So now that those are the different levels of thinking. Okay, fine. So now when you have the different levels of thinking, the third topic we discussed is how we are going to understand the different natural systems. So can somebody briefly explain what is the understanding process we discussed in the last class? Because you did some assignment also. So what is the understanding process in which we try to understand systems or try to understand natural systems? Anybody? Or shall I take names?
Sir, we observe a system and then we take a keyword to expand our bias, like to bias it, and then think around it, try to connect it.
What is the first step?
So observing the system and then trying to think and then connecting the keyword and thinking the keyword first. Like
Okay.
Sir,
Then,
all natural systems are
Manifestation of
manifestation
knowledge.
of knowledge.
yes. So first you look at something in the nature as a
Manifestation of knowledge.
manifestation of knowledge. Then when you look at something as a manifestation of knowledge, then what you have to gain from it?
Information, the information
Yes,
flow.
the information. In order to gain the information, there should be some,
Information flow.
Experience. Okay.
yes, there should be some direction, some perspective. Am I right? For that, you need to create some keyword or some perspective. Okay. So after that, with respect to that perspective, if you get information, then what next?
An interpretation.
An interpretation, right? So once you get the information, then the analysis happens, and your interpretation will be different to that of others' interpretation. So this is the way generally we understand natural systems. Considering this as a manifestation of knowledge, then get the information. If it is unbiased information, that is fine, you get it. Unbiased information, if you are unable to get, create a direction and perspective, then get the information, analyze, interpret. But don't think that all interpretations will be same. No, all interpretations will not be same. Point to be noted. So they will be different. Okay, so that's the reason why the way we understand natural systems and the way interpret natural systems should be in such a way that that will create some technology or that will create some product. That is what generally we do. Okay, so that is what the way generally we understand. But before creating some knowledge, before creating the some technology, the deeper understanding of that system is most needed. Am I right? So deeper understanding of that natural system is needed. So deeper understanding of that natural system is very much required. That's why we kept this course as bio-inspired design, because prior to the product development, prior to the technology development, what we are doing is understanding system thoroughly, understanding a well-developed natural system thoroughly, understanding a well-developed natural phenomena thoroughly. So that is the reason why it is coming under design. Otherwise, I would have told this bio-inspired engineering, right? So that is where the understanding process come into picture. The deeper you understand, the better your technology would be. Deeper you understand, the better your insights will be. Okay, so that is the reason why the understanding process of these natural systems are is most important, which we must consider. Hope everybody did in that direction. So when somebody say that it's a manifestation of knowledge, it's a manifestation of knowledge means what really you look at, because I'm not giving any bias. Okay, so in front of you one photograph is there on the slide. Okay, on the slide there is a photograph. Now look at it as a manifestation of knowledge. Then what you actually look at it? Because we have different perspectives, different levels, and the way of thinking also we know. And without biasing, if you see that photograph, then what you are going to get?
So you would get like the different attributes of the system that make it special in this sense.
No. My question is, previously you learned about how to think or how to understand the natural systems. In that particular category, the first step is looking at something as a manifestation of knowledge. So here, looking at something a manifestation of knowledge means what? What do you see there in this photograph?
It's like what basic forms of knowledge can create this sort of system or create the complexity of that system in that sense, right?
The basic forms of knowledge that create this system. So are you talking about the materials?
Yeah, the materials, the behaviors of the system, things like that, the components of the system.
Structure.
Yeah.
Mhm. So material, structure, behavior, all those things you can't say from that image. At least uh, materials and structures we can talk about. But most of the time, we always think in this direction. When you look at something as a manifestation of knowledge, you look at with the mindset that cause and effect. That we call in physics as a principle of causality. In engineering also, what we call that? Principle of causality. Okay, so that means if there is a cause, there is a effect. Now you tell me, are you observing the effect or the cause? If I ask you to see that photograph and tell how you need to see, you need to see as a manifestation of knowledge. Okay, in that case, are you looking at the effect or are you looking at the cause?
So the photograph C is sort of the effect
No, no.
of this.
See, whatever the photograph I will show you. So this is the lotus leaf. Okay, the lotus leaf. Then, if you want to see something as a manifestation of knowledge as per your understanding process, then what you look at? Do you look the system as a cause or event? Sorry, effect. Where you look at?
So maybe we'll look at like effect and then we try to connect it with the cause.
We generally observe the effect, then try to connect with the cause. Can somebody say what is the effect here? Can you see something?
So the water droplet is like it's water repellent. The surface is water repellent.
Surface is water repellent. That means hydrophobic. Preetham wrote hydrophobic. That is correct. So whether the hydrophobicity is the effect or a cause?
So effect.
Effect. So when you find this effect, then you are going to search for the cause. Am I right? So what is the cause here? Cause is this structure. As somebody said in the beginning, somebody said, I'm going to observe the material, I'm going to observe the structure, I'm going to observe the behavior. These are all things coming under the single line. What you are going to observe in nature is the effects and trying to probe the causes. That's it. In order to understand, that is most important. Not only this one. In nature, any system you take, if you consider something as a manifestation of knowledge, then you are going to look at effect and cause. Mostly you are trying to understand causes. Why this particular effect is coming out. Okay? So all your features, whichever you explain, are nothing but effects. But there should be some cause. You have to understand the cause, then engineer it. Am I right? That may be biomimicry or bioinspiration, but you must understand that. So please remember, if you are looking at any system as a manifestation of knowledge, then you have to look at all the effects related to that system and all the causes in that particular system for those effects. So cause and effect model you should follow in order to find some knowledge in that. Okay, so that is one way to gain knowledge. Okay.
So,
Yes.
is there a situation where we need to, like, where we might need to see for the cause first and then look for the effect?
Yes, yes, both ways are possible. Both ways are possible. I'm not saying only we have to look at effect then cause. No, no, no.
Yeah,
Okay.
like both are.
We can observe something and explain that as a cause for something else. Okay.
Yes.
Yeah. So this is all like an investigation. Okay. Is this the cause for something else? And is this particular thing create something else? Because this will become cause and that will become effect. So both are possible. That means you can observe the cause, you can observe the effect, then explore. That means you are gaining some understanding. So what is the second step in your understanding process? Gaining the information. The once you start understanding this natural system with respect to cause and effect, keywords by default you will come to know. Because somebody said, now what is the effect? Hydrophobicity. Then hydrophobicity means my keyword is hydrophobicity. So if I search a hydrophobicity, then hydrophobicity is the effect, then I'm going to learn about the cause. So relevant information I'm going to get. So once I created the keyword and getting the relevant information, that means I'm getting the information related to cause or effect.
Cause.
Cause. Okay, that means all your knowledge lies in observation of the cause. Okay, effects are more important, no doubt about it. But once you understand the cause, then you can say, I understood this system. Okay, now you need not to search for the keywords. You just follow this philosophy: cause, effect. Generally, effect will come in your observation first, and you are going to probe for the cause. In this case, hydrophobicity is the effect which you see directly, and the pattern or the structure you are seeing in the photograph is the cause. That cause actually introducing this effect. Okay, now you have the keyword also to search or to get the information. Okay, now your interpretations can be anything. Okay, one of such interpretation is hierarchical construction. So what is hierarchical construction? Now you see, these structures are responsible for rich physical and chemical phenomena. Here what you are seeing is the structure of micro, you call them as pillars, you call them as domes, okay, micro dome structures. Okay, now you tell me why I called them hierarchical. So now you search in your mobile phone or a computer, what is mean by hierarchical structure or hierarchical construction? You please search. Hierarchy means what? Hierarchy means what? Pyramid structure. Mhm. Hierarchy means pyramid structure. Eh?
Sir,
Krishna,
hierarchy means levels of things. One thing is above something, something like that.
Sir,
yes.
so higher priority objects are at the top of the uh, model, and then it goes down as per the priority decreases.
Correct. So Venkata Nagasai wrote that, sorry, Dikshita. Dikshita wrote that arrange in order of rank on or levels. It's a kind of ranking. Okay. So in this structure, if I set this as a hierarchical construction, what do you think hierarchy there? Why I said hierarchical construction? Can somebody reflect on that one, please? Why I said that? Photograph is in front of you. Why I said hierarchy? Based on sizes. Means what?
The top level objects are built from lower level.
Like layers, sir.
Layer.
Layers are.
Layers. Okay. So here, how many layers you see in the uh, in that photograph? Are there any layers? Because somebody said the ranking or order or layers. Let us assume that anything you take, how you get some information with respect to that keyword. Suppose if I say layers, what layers you see there? If I say arrangement, what arrangement you see there? Just like that, I can't say hierarchical construction. There should be some logic. Am I right? Yeah, what is that? You see and tell me. Hope this photograph is clear for everybody. Shrestha wrote that interaction between each levels. Sorry.
Sir, at the lowermost level, the construction is similar to that of the level on top of it, and this construction is still same on the level at top of it. It's like
That means you are saying all the components are same or different.
arrangement is similar, but components are different.
With respect to
Sizes and shape.
size, shape.
Shape.
Very good. So suppose, let me just a minute. interaction between each levels. Yes, Shrestha, could you please elaborate on that? Continuous base and discrete arrangement. Yes, Shrestha, could you please elaborate on that interaction between each levels?
Am I audible, sir?
Yes, yes.
Yeah, like I told with respect to the hierarchy in an ecosystem,
Hmm.
like we have like
No,
different.
in this photograph,
Hmm.
you see hierarchy with respect to what? Because you said interaction between each level. So, what kind of that hierarchy you see?
Sir, uh, in the picture C, 50 micrometer picture, that picture, we can see there are a lot of pillars. And then in 5 micrometer G and H picture,
Hmm.
each one pillar is then further zoomed into.
Hmm.
And then each pillar is made up of the thread-like structures.
Hmm.
So then we can see that at 50 micrometer, it's first discrete cylinders, and then further each cylinder is further made up of discrete uh, cylinder or thread-like structures. So that is the hierarchy, maybe.
Okay, that means, can you explain? Because you are all engineers, okay, don't forget that. You are not philosophers. Because you are all engineers, Mayank said, with respect to size, there is a hierarchy. With respect to shape, there is a hierarchy. And you are saying something else. How you parameterize that? Nilesh?
Um, Sir, it just evident from the picture.
Your explanation is perfect. I'm not
Yeah.
disagreeing with that. But we are
Okay.
engineers, right? Not.
Yeah. Sir,
See,
it's it's kind of evident from the picture. If you see the comparison of C and G picture, like up and down, we can see a similar shape emerging out from both the pictures.
no,
Here
from
it's more compact, and the G in 5 micrometer it's more compact, but in C it's more distinct.
you look at only this picture, okay?
Which one, sir?
This one. You are explaining only this. Don't go to this one.
Sir, I couldn't see the arrow. Okay, C picture.
Yeah, A, B, C. C, don't worry. A, B,
Okay.
you look at. So can you define some more parameter for me?
Uh, Sir,
Because size, shape already defined.
okay.
Size of that dome and shape of the shape is anyway dome.
Okay.
Is there any other parameter?
So
Okay.
density of the closeness at which each structure, I mean the smaller ones, they are more dense, and as you go up, the density reduces.
Yes.
Yeah.
Yeah. Preetham, that means the density. Can the density be a parameter?
So number of domes.
Number of domes per.
Or like image, maybe we can say.
Per image.
Per volume, some
Yeah.
measure of volume.
Volume.
Sir,
Where
interest
where
surfaces.
Area.
So
area.
Area.
Number of domes per unit area is the density of domes. Agreed. Next. Yes, Preetham. You said something fractal hierarchy.
Uh, Actually, sir, I explained in terms of like zooming effect. Like the structure when we zoom out, it appears different. When we zoom in, it appears different.
No, that
So
fractal you wrote, right? That
yeah,
fractal nature, which parameter exactly you can give? Which property you can give?
the repeating nature of the structure.
No, that repeating nature of the structure, I think that is echoing. So repeating nature of the structure can be explained by a simple parameter. Anybody, any idea?
Am I audible, sir?
Yeah.
Infinite perimeter, finite area.
No, that also not needed. Why?
So frequency.
Periodicity, am I right? What do you call that in order to tell about the periodicity?
Frequency.
Frequency or pitch you can call.
Pitch.
Yeah. So now size is over, shape is over, pitch is over, then fractal with respect to what else? Fractal with respect to what? Do you see any component of quotient of friction there? Coefficient of friction.
Surface area of contact.
That's it. Okay. Surface area of contact anywhere related to the friction. That means roughness of the surface. Am I right? So the roughness of the surface matters. But even roughness of the surface also, you see how it is varying in a particular dome. How it is varying? Is it same everywhere? Is it same everywhere?
No.
No, sir.
No, it's not same. It's not same. It's vary. It's vary. That's the reason. That's the reason. When you take this particular structure, why we are calling hierarchical construction? Because we are looking at this structure as a superposition of different dome sizes with different surface roughness, with different shape deformations, with different surface pitch, the periodicity. Okay, so whenever you consider the periodicity, the density of domes also will change. And can you say density of domes is constant? Density of dome, is that constant?
No, sir.
Yeah.
Not necessarily, sir.
So it's not constant. So we are just considering this particular structure as a superposition of different domes shaped, different shaped domes, different density dome patterns, different domes with the surface roughness. Okay, so it is, you are not considering it as a single structure. It is a superposition of different features. It is a superposition of roughness, size distribution, shape distribution, and density distribution. Okay, and surface roughness distribution. So it is not single structure. It is a superposition of different size distributions, different shape distributions, different density distributions, and different roughness distribution. Will you agree with me? Any counter on that? That means whatever I have shown in that particular image, I'm not at all considering as a single structure. I'm considering it as a overlapping or layers of different structures or a different kind of structures. Will you agree with me? Or any doubt on that?
Yes, sir.
Yeah. So that means instead of considering as a single structure, I'm considering it as a superposition of different structures. In this particular case, you can define the distribution of the shape, distribution of the size, and distribution of the density, and distribution of the roughness. So these all actually different varying layers. So when you consider that as different layers, that means different sizes domes are one layer, different shape domes are another layer. So number of layers are there. Then different roughness is another layer. Okay. So when you consider as the hierarchical construction, layered structure, that's why you called this as a complex hierarchical construction. So this hierarchical construction, how you are going to parameterize? Because in order to explain something, you must find some parameters first. Otherwise, you can't explain. Philosopher can explain in any way, but engineer cannot explain. Scientist and engineer cannot explain like that. You have to find some parameters. In this case also you defined parameters. What are those? It's not size, it's a size distribution. It's not shape, it's a shape distribution. It's not height, it's a height distribution. It is not roughness coefficient distribution. Okay, so you can define like that, different parameters. So once you define the parameters in a particular system, that means you have the complete picture and information of about that particular effect. So what is the cause of that effect now? The cause of the effect is this structure. What is this structure? This structure is a superposition of different size distributions, different shape distributions, and different roughness distributions, and different height distributions at micro level. Because of this structure, this is the cause. This cause is creating an effect called hydrophobicity. Okay? So, what you named this particular structure? You named it as hierarchical construction. Why you named it? Because it is very complex. So complex means, simply if you say complex, nobody will understand. That's why you kept it as hierarchical. That means even though it is complex, I am understanding this complex structure as a layered pattern. Layers means don't worry in the only in one direction. No, need not be. You are considering this as a superposition of different size distributions, different shape distributions, different density distributions, different roughness coefficient distributions, different height distributions. Those are all layers, different ranks, different features of that particular structure. So that's why you are calling it as hierarchical construction. That means, point to be noted, in nature, wherever you consider or you see very complex structures, you don't leave them like that. You understand them with respect to some parameters and consider them as a hierarchical construction. You understand them as a hierarchical construction. So that is what the information you are going to get with the philosophy of cause and effect. Effect is hydrophobicity, and cause is the distribution, the structure. The structure is named as hierarchical construction because it is complex. Why you are using hierarchical word? Because you are considering this complex structure as a superimposition of different structures. Okay, that concept they got from the nature. That means if I superimpose different structures into single, I'm going to make complex patterns and complex structures. That complex structure actually leading to new features that may be chemical or physical. Okay, so that is what they tried here. So what they tried is, again, we have some limitations. That's the reason why first they went for the regular pattern. Here, one feature is missing. With respect to height, is there any distribution in this? With respect to pillar height, is there any distribution in C here? Where the cursor is there, that structure I'm talking about. Sorry, wait a minute. This structure. This one also. This one. In this, is there any height distribution? Can you see any height distribution here?
No, sir.
No. Is there any size distribution?
No.
No. Is there any shape distribution? Any variation in shapes?
No, sir.
Very minimal. That means almost no. So, and what is the other one? Density. Density of domes, right? So, is there any density of dome distribution here? That means number of pillars per unit area. Yes or no?
I think no, sir.
No.
It is evenly distributed.
Yeah, it's evenly distributed. That means initially what we thought is we wanted to understand this as superposition, but initially what we can do is they did removing all the complexity, they made into this particular structure. They arranged in a regular fashion. They removed the size distribution, shape distribution, height distribution, roughness distribution. And is there any roughness on the each pillar? Almost no. Okay. But if you see the G here, this structure and this structure, what you can see? What you can see here? Because in this case we don't have any other parameters followed like this one, natural inspiration. But here,
Kind of random pattern.
yeah, it's a first is random pattern. What about the size distribution?
Yeah, it's uneven, sir.
Yes, so there is a size distribution. Is there a shape distribution here? You just see closely. Is there a shape distribution?
Yes, sir.
Yeah. So that means size distribution is there, shape distribution is there, and density distribution is clearly visible. Okay, because some areas it is clumsy, some areas are higher dense areas, and some areas are lower dense areas. So density variation is very clear. So density distribution, size distribution, shape distribution, all are followed. That means only roughness distribution they might not have followed here. So other parameters are introduced. They fabricated. Both shown the hydrophobic properties, very good hydrophobic properties. Now tell me, if I give an option, which one you will choose? CD or GH? What I'm doing, I'm giving you the option. You choose one pattern. Which one will be more effective in your opinion? C and D. C and D effective, why?
Because sir, in practical use, I expect it to eventually become like G and H.
No, why you considered C and D first?
C and D because they are highly ordered, and what I expect is it will give more efficient hydrophobicity because there is a even distribution of density, and the longevity of the structure will I expect to be high because even if they get damaged, I expect it to be turn it into like G and H.
Yeah. So anybody else? Any counter on that?
So we cannot make anything random, sir. So as it is uniform and ordered, when we design something by our own, so it should be like this in C and D. So when we plan to make some G and H, it is random. We cannot make anything random. We can make it everything in order way.
Okay.
So I would go with C and D.
C and D. Any others, please?
I will go with G and H, sir.
Why?
Making a ordered things is difficult than making is a random pattern. So if it is depend upon material anyway, by structure it may go for hydrophobicity.
Okay. Next, any others? So question is, suppose if I give you two options to choose these two or these two, which one you are going to choose for the same property? What is the property we are looking at? Hope that you didn't forget.
Hydrophobicity.
Hydrophobicity. So hydrophobicity you considered. So we observed the natural system and made two systems. Here no consideration of size distribution, shape distribution or density distribution and anything else. But only we followed like a mentor. Okay, it is almost like a mentor. But here we followed size, shape, density, all distributions except the roughness density. roughness distribution. So then what you choose and why? Because that, which one you really call as a hierarchical construction? If you really want to call as a hierarchical construction, you call CD as a hierarchical construction or GH as a hierarchical construction?
Sir, GH.
GH is the hierarchical construction. Why?
Sir, more number of parameters are being varied over here than C and D.
Yeah, more number of parameters are there in G and H. Now tell me, as far as the effectiveness is concerned, whether C and D or G and H are, which are going to be your choice? Anybody, not only you, anybody.
Obviously, as G and H is very similar to the actual system of A and B, so it would work more similar to the same system.
Right.
So in that case, I would go with G and H.
Okay.
But when there is no difference between C and
selected everything, Jay Pratap.
Yes, sir. So initially the condition you told us that C and D and G and H works in the same way. There is no any difference between the C.
No. As Hemalata mentioned, please, everybody listen carefully. When we are talking about the hierarchical construction, we have multiple parameters at a time. They are all variables. Multiple parameters at a time. They are all variables. In that particular case, then only we call it as a hierarchical construction. Otherwise, we should not. This you should not call as a hierarchical construction. But still, it is giving the effect. Still, it is giving the effect. But if you want to really build the efficient hydrophobic structures, you have to go for real hierarchical construction where you are dealing with more than one parameter. More than one parameter. So here we are dealing with more than one parameter. That's why it's a hierarchical construction. And fabrication wise, building regular pattern is difficult than random pattern. Building regular pattern is difficult than random pattern. Okay, so that is the reason why we go with G and H, which is also effective. Maybe control is difficult, but they are very effective. They are very impactful. Okay, so that is the reason why in this particular slide you must have heard 3 different points. One, how to understand the natural system. This is the practical case. What is the philosophy you need to follow while understanding the natural system? You know the process, but what is the philosophy you are going to follow? What you are going to observe?
Cause and effect.
Cause and effect. Okay, so you are going to observe cause and effect. You are going to follow the cause and effect philosophy in any natural system because you are considering it as a manifestation of knowledge. So what when you say manifestation of knowledge, you must know what is the cause for every effect. Okay, so then information, all those things, you know the process. So when you are following the cause and effect model or philosophy, then here we are defining this structure as a hierarchical construction. Why? Because here this complex pattern or complex structure we are considering as a, anybody? How we are considering this complex pattern? Please note down. Everybody, please note down. We are considering the complex structures. We are considering the complex patterns as a superposition of different patterns or a superposition of different variable parameters. Okay, please note down. We are considering the complex patterns and complex structures as a superposition of different patterns and different structures. Or simply you can write, we are considering the complex pattern as a superposition of several variable parameters. Okay, in a single system, if you are going to define too many variable parameters, then it is the hierarchical construction. Okay, so that means nature is always following different hierarchical constructions to exhibit different effects, different phenomena, different features. Okay, this is the second example. What is this? Butterfly. That blue color, that blue color, now these days blue color becoming famous. Why? This particular blue is famous. Why? Tell me, in your engineering point of view. Hard to fabricate. Now this blue color, they are specifically giving to something. It's almost became like a symbol of something. Any observations on present trends? Company logos. Think.
Sir, it is like eye catchy, what we like. It grabs a lot of attention.
Dikshita, could you please elaborate on that, ma? Dikshita. People are typing faster than talking. So she wrote electricity. Maybe a lot of noise is there. It's okay. So electricity she wrote. So you just have a look at the e-vehicles, electric vehicles. What is the most preferred color for electrical vehicles they are giving? Two colors are there. One of them is blue. Okay. Second is green. Okay. That green because of what? You know the logic?
Eco-friendly, right?
Yeah, that is eco-friendly. Why blue? Because Dikshita said electricity. How you are correlating electricity with blue color?
Like it's the high voltage thing will be visible in like brightest white, but
No,
it comes in,
brightest is yellow, not blue.
yeah, like the shade will shift, right, sir, between blue and yellow, sir.
Blue and yellow. Yeah.
Like yes.
You don't know. Even I don't know the reason. What I am
So,
thinking is,
and also, like we've been shown from our beginning that the lightning and electricity colors are blue. I mean, like it's been a memory since so long.
exactly. That lightning is the correct thing, because our perception of electricity is a spark. Am I right? The spark, that lightning comes in the blue sky or in the sky. So maybe that is how we are going to perceive is lot of discharge will happen. Sometimes you see them as violet and blue. So maybe because of that perceptional, that's a human perception problem, okay? Because your eye can see like that. So insect won't see like that. Any insect or some other creature won't see like that. So he is perceiving electrical lightning as blue color. Maybe it is also indication of the natural form sky. So they are giving these two colors, especially symbolizing the e-vehicles. You can have a look at it. Okay, so that is the reason why this blue color is coming in this butterfly. Can somebody please parameterize this one quickly? I think it's time is up. Anybody? Any parameterization? So you do one thing. You take a photo. Yeah. Somebody saying.
I was thinking that maybe the layering of the wings.
No. This is also hierarchical construction only. But hierarchical construction of what parameters?
I think like the scales of the butterfly wings. So they, because of them being translucent, they'll sort of like interfere with each other to give that this very variety shade of blue. in that sense.
That is true. That is true. What you are saying is cause or effect?
The cause.
What you are saying is the effect, because appearing blue is an effect. But what is the cause inside?
The layering of the scales. That's what I say.
So layering of the scales. So take a photograph of this. Okay, tomorrow we will meet again. Take a photograph of that. Or screenshot. If you are listening in a mobile phone, just to take a screenshot. Next step. This one also. Please take a
Sir,
screenshot.
1 second.
Sir, you take this one first because time is up.
Done.
Okay. Next, this one also you take screenshot or photograph. Okay. Then please parameterize and come tomorrow. Okay. Tomorrow what time we have the class? Tomorrow 10 to 11, right? So 10 to 11 I will ask what are the parameters of these two structures. Okay. So parameterize, and I am telling both are hierarchical constructions. The minute I say hierarchical constructions, you should find the superposition of different parameters or different structures. Superposition of different structures or superposition of different variable parameters. Okay, in the same structure. So you have to find different parameters and you have to say why it is hierarchical. Why I am saying this, these are hierarchical, both. So that I will ask you immediately tomorrow, 10 to 11. So, yes, Mahima, the attendance is over.
Over, sir.
So if you have any questions, another 6 minutes I am there. You can ask. Any questions? Open discussion.
Sir, not everything necessarily has a hierarchical structure, right?
Sorry?
Not every system necessarily has a hierarchical structure.
No.
No, right? Yeah,
No.
okay. That's one.
No. We have to look at it and decide. Suppose there is only one parameter significant, then how can you say it's a hierarchical?
Yeah.
And also you see, maybe just for curiosity, this thing, you can see here, if you see this one, this is more hierarchical than this one. Will you agree with me?
So can you repeat that?
This structure you see, this one, this structure is more hierarchical or more complex than this one. Will you agree?
Yes, I think, yeah, I agree.
Correct?
Yeah, it has more different subsystem, sublevels.
Yes.
Yeah, in the hierarchy.
There exists some periodicity here.
Yeah.
So distributions are little less if you compare with the previous structure. So that's why that hierarchical construction in any, we can't say everything is hierarchical. At the same time, there is a difference in complexity also. Difference is there. So that we must look at the system, then decide. No, actual thing we need to understand, what we need to understand from these structures, I will tell tomorrow. Because hierarchical construction, that means I can create complex structures by overlapping different patterns. Okay, fine. Is it possible, and is it possible in computer science? Suppose if I give that hierarchical construction inspiration, will you build a very good software system for some purpose? So that way, generally, we have to think. Now we are only understanding these natural systems. In the later part, we have to apply that understanding to some purpose. Then only our bio inspiration will complete. Okay, that we will discuss tomorrow. So yeah, you can stop this recording. So that we will